So that's me. And I think it's a great pleasure to be here. Thank you, Tina, and allowing me to talk on this fuzzy issue on the policy relevance of paleo research in Kenya. So I'll proceed to go through this, and I hope that you'll be paying keen attention. It is a thematic area which is open to a lot of, personal views and interpretations. And yeah, so let's see how it goes. Okay, so we'll start off with the broad policy context. Remember that I'm focusing just on the African continent, and that is basically what we want to discuss about. So we, first of all, have to recognize that we are facing a challenge. And it's put in 3 words, basically, as being beyond the natural variability. So we see that humanity today is facing a lot of problems in terms of how we have actually interacted with the environment and our environmental stewardship of the planet. There's a lot of natural resource depletion, and in many places we have exceeded for the renewable types of natural resources, the rates at which they can be improved, they can regenerate. And we also see adverse impacts of environmental degradation, and there are many forms of this, including desertification. And this is also largely related to, just poor environmental stewardship of the Earth system. I wouldn't just pin it down to an increase in the population, but it's that we have a population that is increasing with very little regard to environmental conservation. And we see those various links. Then, of course, we're facing a lot of freshwater scarcity, and particularly in the African continent, within the tropical regions and even the subtropics, it is a major, major issue. We have freshwater scarcity on seasonal basis and sometimes over longer periods, which are related to droughts. And then the issue of the loss of biodiversity, which is basically a global problem to date. And all of this together, really put us in a very dire situation. And that is one of the reasons then that we came up globally with the Agenda for Sustainable Development, the 2030 Agenda, which we now are more familiar with when we just talk about the Sustainable Development Goals. However, we scientists recognized this, of course, a long time ago. And in 2001, that's about 20 years ago, the Earth System Science Partnership declared an urgent need to develop strategies for Earth system management. And of course, you cannot develop strategies for Earth system management without considering the policy and the governance environment. Okay, so here we have a pictorial of our Sustainable Development Goals. And out of these 17 different goals, we can pick out some to which we can directly, of course, relate. Which is goal number 6 on clean water and sanitation, goal number 13 on climate action, goal number 14 on life below water, and goal number 15 on life on land. And of course, underpinning this, we also fit into goal number 4, which is a quality education. And then we need to recognize that all of these goals are in some way interlinked. And we are not going to really go into those interlinkages, but at least we can see that even within the Sustainable Development Goals, paleo researchers have a role to play directly and very prominently in the goals that I have actually called out and mentioned. But we do have also, for the African continent, the Agenda 2063 developed by the Africa Union, and it has 7 goals. And we're looking here at the 7th goal of Agenda 2063, which is to have an environmentally sustainable and climate resilient economies and communities. And the priority areas which are outlined under that agenda are biodiversity, conservation, sustainable natural resource management, water security, climate resilience, and natural disaster preparedness. And each of these link up with those particular goals that are outlined under the SDGs, 6, 7, 13, and 15. But we also have another important strategy document for Africa, which is the Science, Technology, and Innovation Strategy for Africa 2024, normally referred to as the STISA 2024. And it has basically 6 major priorities: eradication of hunger and ensuring food security, prevention and control of diseases, communication, protecting our space, living together, and also creating wealth. And we do see that all of these different 6 priority goals are very, very tightly looped in with the water cycle. We're looking at things like water availability, the water quality, river regimes, the hydrological cycle as a whole, and also in a more general scope, water resources as, you know, a foundation for economic wealth creation. And it is recognized, of course, that if you're looking at the bottom panel there is a political dimension to all of these things. And then there's also the dimension where different actors interact. That includes the scientists, the private sector, civil society, funding agencies, as well as you know, institutional and public structures that carry out various different types of activities. But I think one of the main things here to notice that the contribution of water is basically cross-cutting across all the STISA priorities as well. Now, we do face in Africa quite a number of different challenges, and here I've basically tried to summarize some of these against 6 different thematic areas. One, of course, are the environmental issues. I've already mentioned that here we do experience extreme hydrological variability. We also see a lot of pollution of land and also water. And there's also a lot of sedimentation occurring. The sedimentation rates have increased, you know, at least 2-fold or more across the continent. And most of our waters have become quite turbid. And in general, there is a general warming of the atmosphere, warming of the land surface, warming of the waters, like the lakes especially. All of these have been warming consistently over the past 50 years or so. In terms of the ecological aspects, we see changing food web structures, and if we're focusing on lakes in particular, eutrophication is a major aspect there, as well as anoxia and algal blooms. In the terrestrial sphere, we also do come across a lot of species extinctions and invasions, and also the introduction of new species, both in the aquatic systems and terrestrial systems, that are really creating problems within the ecological makeup of the continent. Ecosystem goods and services are, of course, being depleted. We see a lot of degraded wetland resources. We've already mentioned the pollution of the water resources and also the land resources, but then also with regard to environmental degradation, we see our forests cover declining, the soil characteristics are changing, and in essence, all of these are leading to reduced livelihood options and also minimizing some of the aesthetics of the African continent. But then there are economic effects. And one of those is the so-called poverty environment trap. And while people recognize that indeed there is a relationship between environmental degradation and poverty, the the linkages between them and the causal loop pathways are not yet actually very well elaborated upon. But in essence, we see that our resource values are reducing. But we're also facing new and competing demands for environmental space. And you can see this, for example, because across the African continent, there's been an upsurge in exploration for mineral and oil and gas resources. And these are creating new and competing demands for resources like water, for resources like land. And in addition to that, in order to meet the kind of deficits that we have, we are also now in the process of constructing large dams across the entire African continent. And of course, the flagship one that we can think of is the Grand Renaissance Dam in Ethiopia. But there are many others which have been planned. And not only large dams, but also major interbasin water transfers. And these dams are supposed to be multi-purpose dams, generating, for example, water for agriculture, irrigation and agriculture, generating power, hydropower, and others. And then we have social issues that are related to those displacements. And whenever we have displacements, displacements occur over space. So displacements basically lead people into more fragile land areas and also bring up a lot of resource-related conflicts, generate new competing demands in areas that are occupied by the displaced people, malnutrition because they are in an environment that basically yields very little and therefore livelihoods are also lowered. And then governance is extremely important. And we have a lot of good things that we've talked about already before. We've talked about, the African continent countries subscribing to the SDGs, subscribing to the Agenda 2063, and also incorporating and domesticating all of these agenda into very well articulated national plans and visions for the future. But governance is also constrained by a number of factors, including, multiple jurisdictions and confounded mandates between different institutions. There's also a very sectoral approach, which and if you can think of it in this manner, the sectoral approaches basically result, for example, in a positive positive benefit in a particular area if a particular action is taken, but it may have a negative impact in another sector. So coordination, which is also needed, is lacking. We also do know that we have so many international river and basins in Africa. I think there are about 63 or so. And these require transboundary cooperation. Big lakes like Lake Victoria and many other lakes within the Eastern Africa region are also transboundary. And one of the major constraints also is that the governance approaches have not really been participatory to the extent that the people on the ground, the grassroots citizens, who as individuals can each contribute their part to good environmental stewardship, basically do not have the opportunity to do so and are not receiving the knowledge and education and awareness that is relevant to be able to participate meaningfully in good earth stewardship. So we also note the issue of climate change, which is superimposed on these environmental problems, and it basically just confounds the entire situation, okay? And one of that is because our livelihoods here in Africa are highly dependent on these natural resources. And we have seen already that we have very intricate socio-ecological systems as a consequence of that interdependency of man and environment. And therefore, we also have a lot of stakeholder groups that are interested in the same issues, but with different viewpoints. And therefore, it is very hard to come to agreements on how we want to move forward in terms of environmental stewardship, in terms of taking care of the planet Earth within the Africa. So we also recognize is that because of this complex problem of climate change, and we need to have multi and transdisciplinary approaches that can help us to deal with this issue. But there's also the problem of large uncertainties and incompleteness in data and information, which I'm going to explain a little bit more further down in this talk. And the other aspect of capacity constraints, which we have in terms of both generating and also utilizing the knowledge that we have. So it's important to generate state-of-the-art scientific knowledge. But I want to bring us to this figure here on your left, which basically illustrates, some of the complexity of the climate change problem. So we have dynamic complexity, the generative complexity, and the social complexity. Now I want you to take this particular figure and extend those arrows in the opposite direction. In essence, we are extending these arrows into the past. So we can think of the issues of dynamic complexity in terms of climate change, where we are unable, we see that cause and effect are separated in time and place. So an action that is taken today is going to have a specific kind of result or outcome, say 20, 30, 40, 50, or 100 years into the future. But we cannot be able to really say these things for sure. If we go back into the past, we are able to see from the record of the past, how cause and effect interplay depending on what actually causes, or what is the primary driver of change. So we can look at those aspects. So in terms of dynamic complexity, we can help to reduce the uncertainty about what is going to happen in the future by looking at the issues of dynamics in the past, where we can actually see cause and effect, because these are things that have already occurred in the past. There's the issue of the social complexity. And again, if we extend this to the opposite direction, we will be able to see how the changes in our society have occurred through time and how those changes have actually affected the environment. And there are very, very many examples of these kind of interactions, human-environment interactions, that have been studied as a consequence of paleoresearch work that have generated very useful and interesting information about the future. Then the other thing is that we also have the generative complexity. And this is because climate change is basically a new problem. We are really unfamiliar with it, and we are basically learning our way towards a solution. And again, we can look at this in terms of the issue, for example, of the fossil record. When you look at the fossil record in the past, there are certain aspects and things there that we just hypothesize. They are not yet things that are taken as absolutely factual. And I think there was a very interesting paper that recently came out in Nature that is basically trying to see, what really drove the species rejuvenation, different species rejuvenation, or even came up with new species following major extinction events in the past. So, this kind of work, looking at things that have already occurred, also help us to understand the boundaries of what may actually happen in the future. So how do paleo researchers fit into this mix? I've talked a little bit about that. I'm looking at that diagram, but let's look at it a little bit more. First of all, is paleo research really relevant to policy in Africa? And I say a resounding yes. Of course, our meteorological as well as other types of environmental records and written observations are temporarily limited. Okay, they don't go back more than a couple of 100 years, and particularly in terms of climate records, these ones are basically covering the past 100 years or so at the most. So data on long-term cyclical fluctuations is extremely limited. I think we can all remember when we were in high school and were told that, if you really want to have a good kind of statistical data set to which you can, look at some of the statistics properly, parametric statistics, then maybe as a rule of thumb, 30 data points is really good. But now imagine if we're trying to look at decadal scale or longer scale cycles, and we only have over the past 100 years, 10 points for looking at that. It is extremely tenuous, whatever outcomes we will come up with. Also, we have problems about how these changes in terms of how the climate changes, for example, affect environments and human societies, and how all these three facets basically interact to generate outcomes that can be seen and recorded. Paleoresearch also gives us an historical perspective on the magnitude of past variability. And here we're talking about natural variability. So we can determine then, is this variability changing as a consequence of, human factors, or is it just within the natural bounds of variability? And this kind of information is extremely important because it gives us a baseline for efficient long-term management of our natural resources. And here, when I'm talking about long-term, I'm talking about interdecadal scale and longer timescales. And we really have to begin to think increasingly about these kinds of timescales. Our research helps us to discriminate between natural and anthropogenic perturbations of the climate and environment system. And I've already explained how that happens. We can look at the past where humans were extremely few and maybe not really having any substantial impact. And now where we have so many humans and they are overprinting the impact of natural variability on the environment. Knowledge of long-term climate change also is necessary for us to be able to assess the significance of historically documented and modern day climate change. And it is also critical in the development and testing of models, and that is something which has been well known in this particular field. So models that are used to produce scenarios of the future should, of course, first of all, be able to reproduce the scenarios of the past that we have generated from paleoresearch studies. And we can also see human impacts which are really significant at different scales, whether it is local or at regional scale. So we do have very many archives in Africa, and a whole list of them are given here. And many of our archives are related in one way or another with water systems. Okay, so most of the stuff that we get are basically from marine environment around the African coast, from our lake sediments, from the different lakes that we have. And we can even get these from reservoirs that have been around for some time. And we also have the peat deposits also associated with the water systems, groundwater, corals, speleothems, and ice in glaciers, and geomorphological features. And many of these are basically related to the water signal. And this particular diagram here shows many of the different sites where we have studied within the Eastern Africa region. And of course, there are many other areas across. So we do have many archives to generate the data that we require. And we use many proxies from these different archives. Okay, so we can see, for example, we can talk about strand lines, like in this figure here, or picture rather at the bottom right. Okay, so we can see, a strand line there, which basically marks a former stable position of the lake system. So in this way, we can tell, the changes that have occurred in terms of lake level, etc. We have valve deposits, and then we have various biological indicators like pollen, spores, polynomos, phytoliths, diatoms, ostracods, chironomids, foraminifera, dinoflagellates. And because many of these different organisms produce shells, normally from calcium carbonate, but sometimes from silica if they're from the oceans, they enable us to, we can also look at the geochemistry of their shells and determine from the geochemistry of those particular shells, looking at stable isotopes, for example, or other features, we are able to determine and relate those particular changes in a manner that we can actually come up with transform functions that allow us to relate those changes to temperature changes. So this diagram here on the complete bottom left is basically showing the stable carbon isotope analysis of foraminifera in surface and groundwaters from in surface water and in benthic foraminifera in surface sediments, I think of the Atlantic Ocean at that time, and showed that there was a very clear relationship between the stable isotopic composition of the shells and the temperature of the water. And so these kind of relationships allow us to come up with really quantitative and confident estimates of the changes that have occurred in the past in terms of temperature, for example. And on the far right at the top, we have a nice pollen diagram there that basically shows us how the vegetation has changed in a particular area. And of course, these can indicate to us local changes, and they can also tell us what are happening at regional level scale. And then on the top left, we have a nice little microfossils there. And you can see these under scanning electron microscope. They're extremely beautiful little things to look at. But they also have extremely, definitive features so that one can easily differentiate them. And thereby we are able to look at much more complex details concerning their ecology and issues like productivity, etc. There are, of course, new and upcoming techniques which are being generated. And there's also the effort to increase the resolution of those particular of the cause that we look at. So we do get a lot of information. We can talk about the paleoecology of an area. We can talk about changes in precipitation or changes in temperature, as I've mentioned. We can look at paleohydrology, how have, say, lake systems changed over time, in terms of pH and in terms of other parameters. We can look at sea surface temperatures and lake surface temperatures using a suite of indicators as I've reflected there. We can look at changes in salinity, in lake or ocean circulation, and in the movement and deposition of provenance, movement and deposition of atmospheric dust. So there's a lot of information that we can get that can actually feed into what is required for policy and decision makers in the long term. Okay, so here let us look at a little bit at, what is the opportunity context for this kind of work that we are doing in terms of, influencing the policy environment. One, we recognize today that we have rapid societal and global environmental changes that are occurring. Number two is that our key economic sectors, agriculture, livestock, water, energy, health, wildlife, tourism, are all highly impacted by climate change impacts. And these basically really depend on the quality of the land and the quality of the water that is available. Okay, so these are the little bits that are here, which I've included in a slightly, I think, purplish font, might be a bit colorblind. Basically things that we can look to later, but I think I want to also emphasize the very last bullet here at the bottom, that there's increasing private sector and industry involvement in environmental stewardship and climate change and adaptation and mitigation programs to mitigate risks to business. So in essence, even businesses have recognized that it is extremely important to operate in a well-managed environment with minimized risks from things like climate change. And so they are really beginning to support a lot more the kinds of activities that are being undertaken by scientists across the board. Okay, so in terms of linking the past to the future, some of the things that we can see in this particular figure, I want to highlight two things. One, that we have to think of things in a transdisciplinary way, but also that paleoresearch can contribute to better understanding of intergenerational aspects. So here we have two photographs of serious drought period here, and people have lost their livestock, and there's also poor production here of crops. But if we look at this record from Lake Naivasha, and the other records also from the region now, and this is a record of the past 1,000 years, which does show that clearly we have had some fairly severe droughts in the past couple of 100 years. And in between those drought periods, we also had fairly wet periods. I think the key thing to note here is that these dry and wet periods were not periods that lasted, on the order of one season or 1 or 2 years. These were interdecadal scale droughts and interdecadal scale wet periods. And so if you're looking at it in terms of changes that are going to happen towards the future, yes, we're going to have short, transient, very rapid changes. Number two, we are going to have some longer term changes, which while they may be changing gradually towards a different level, they may be related with a lot of variability, internal variability, even as that change occurs. And it is from the study of these past records that we're able to recognize that these kind of systems persist within our climate system. And therefore, they give us an indication of what we can actually do to improve on our system. The upper diagram is looking basically at the lake surface temperature from the paleoresearch that has been done in Lake Tanganyika. And as you can see, as you come towards the present day on the right-hand side, this is the year 2000, and it's a record starting from 500 AD to 2000 AD. And we do see that the increase in temperature, which is of the lake surface temperature, somewhat just slightly above 24 degrees centigrade and upwards, has resulted in dramatic changes in the nutrient balance of Lake Tanganyika, basically cutting off fish production. So we can see that, yeah, if we really want to maintain the kind of fish production that we have, we need to limit these temperatures. And this is one of the reasons why, we had the Paris Agreement. But we can also see from the paleo record what would happen, although the boundary conditions would be slightly different from that of today. We can see in the past record, if particularly if you go back several millions of years ago when the boundary systems were different from today, we can begin to see how lakes and their ecosystems were behaving under different conditions. So we improve our knowledge base a bit about those systems, which we can maybe perhaps only understand but not verify through simulations in the present day. Okay, so I talked about that. Sorry, I went the wrong way. So, of course, we do face some key constraints in terms of what we can do. We see that we have spatial gaps. You can see, for example, here in the figure on the right, this is basically just looking at high resolution records, paleo records, and we can see that, apart from, the subtropical parts of Africa, most of the tropical region of Africa is lacking in terms of high resolution very high resolution data from, say, valves, from tree rings, from speleothems, etc. We have other problems there, which include dating uncertainty, the local and regional complexity. Okay, so like, for example, the Eastern African region here has, topography that varies hugely over very, very short distances. So you get very different climatic regimes, or when you just travel a few tens of kilometers, you could be in a totally different climatic regime. We have few low or altitude sites or studies with good records. So much of what we have, for this particular region is looking at basically the high altitudes. And in many cases, quantitative estimates may vary widely within and across multiple proxies at a single site. And this is really, we just need to learn more about what these proxies are actually telling us. So uncertainty in the past and projections of the future are really not a reason for inaction. There's always uncertainty in any kind of research work that we do. If these are well quantified, we can make reasonable contributions in a number of areas, some of which I've listed here and already maybe mentioned before. We can discriminate natural versus human causes of change. We can, of course, supplement scarce documentary records and fill in the gaps within the space. We can extend the range of instrumental records to the past, and if we can calibrate those records that we have from the past with the instrumental records of today, we have more confidence again in terms of interpreting them and projecting them to the future. We can also understand the real amplitudes and durations of variability for different regions, and this is really important for long-term planning. We understand the mechanisms and how climate, environment, ecosystems, and humans interact at various scales. We can see how species evolve and how they're linked to climate and environment. We can determine at local, regional, and global scale which are the most important drivers, what are the likely impacts that they could have. And we can also determine how feedback processes can modify the system. If you have an increase in forest cover, for example, how does that affect the microclimate of a region in the short and the long term? And of course, we also contribute towards the development and testing of models. But we need to address some capacity needs, such as, for example, data and monitoring. As paleoresearchers, we say that the present is the key to the past. Okay, so like, for example, if you are interpreting a vegetation, a pollen record, then you are going to maybe try and understand how does this particular, type of species of tree, what's its environmental niche, what are its requirements today, and what are its, physiological limits of stress, etc. So this kind of information is important. So even monitoring of data and information today serves a lot in helping us also to make better interpretations, again, of what has actually happened in the past. We need also to have capacities to deal with things like integrated evaluations, synthesis, and modeling. Much of this capacity is basically lacking, first of all, in terms of the actual physical resources that are needed. And then also thinking about incorporating advances in ICT, big data science, and AI. And this is already being done to some extent. So paleo researchers are working a lot more with, computer scientists and with physicists and mathematicians, and reanalyzing many of our big data sets in ways that could not have been done before. Scenario development is also key. We can do scenarios of the past, which are very useful, again, to look at scenarios of the future. But I think also that the mapping of the past environment gives people a much better appreciation of what it can be, with good environmental stewardship, for example. Stakeholders can then be engaged in design, planning, and implementation of various activities. And I'm talking here really also about research activities. When we interest our communities in the research that we are undertaking, they are going to have that, give us that much more support and be that much more conscious about the environment. Governance and institutional strengthening aspects, of course, because this is the policy and management, phase. And if it is not strong, then other things that fall under it will also not be. So formal and informal education and awareness creation is important. Many people tend not to really know much about paleo research, and it is something that can be popularized at higher levels. And in my opinion, I think as paleo researchers, we need to also expand our capacities so that we are STEAM, we are science, technology, engineering, arts, and mathematics. So the A stands for the arts. We cannot leave out the arts anymore. I mean, it is really an important component, particularly considering this, global society that we are in. And of course, we need to be able to effectively communicate our research findings. So some thoughts about future work, and this is just some of my rambling. We can do more. I'm sure everybody has their own ideas. We are moving a lot more to multi-proxy studies, which is really the way to go. We're also moving from low to more higher result studies, both in terms of time and in terms of space, like I mentioned. And maybe we need to find some new, I don't know, maybe proxy ways of studying some of the areas where we have gaps, like in the low latitudes, the low altitude areas within the tropical region. Okay, and then we also, in terms of, and this would be very useful in terms of communicating our work, is to move really from vector to raster data presentation of paleoecology. And I've already mentioned about trying to explore new proxies. And we also need, when we're talking about, when we look at many of the papers that we actually currently do have, we still have a problem in terms of looking at issues like leads and lags. And normally that is because we have some kind of constraints in relation to dating control. And these are some of the areas where we can bring in AI to kind of redact these different things and give us a much better information from an analysis of various different streams of data. So that includes the thresholds and tipping points. So scientists today, now you cannot really work on your own. We really need to get together if you really want to have impact. So we work in multidisciplinary teams, and I think that is that is the present characteristic of paleo researchers, and we should continue to do that as well. And also to strengthen our science practitioner and policy linkages. And more generally, we know today that there's this strong drive for open science, and I think it's being driven mainly by UNICEF, but there's so many other different organizations that are looking into this aspect. And it is believed that, in fact, open science enables society as a whole to make better decisions because they are better informed. They have access to all the data that is needed, and they have the capacity to interpret it to the extent that is desired and needed to address particular issues. So I think that should be the end of my talk, and thank you very much for listening.